Students, our next topic is electric field intensity on equatorial line of electric dipole. In the earlier topic, we studied electric field intensity on axial line of electric dipole. To calculate electric field intensity on equatorial line of electric dipole, let us consider that we have an electric dipole having charge minus q at A and plus q at B. These charges are separated by a small distance 2a. Let O is the center of the dipole and let dipole moment of the electric dipole is P is equal to Q into 2a. Suppose we have to calculate electric field intensity at a point P on equatorial line of the dipole such that OP is equal to R. OP R के इक्वल है. If E1 is electric intensity at P due to charge minus Q at A, if E1 vector is electric intensity at P due to charge minus Q at A, then E1 vector will be 1 upon 4 pi epsilon naught Q upon AP square, because distance of A and P is AP. As electric field intensity is force experienced by unit positive charge placed at that point. Since negative charge attract positive charge, therefore electric field intensity acts along this direction. This acts along this. ये direct करेगी. As in this triangle AOP, as AP square is equal to OP square plus OA square. OP is equal to R. OP R के equal है, therefore R square, and OA is A, R square plus A square. Therefore E1 vector modulus is 1 upon 4 pi epsilon naught Q upon R square plus A square. Let E1 vector is represented by, PC vector. This is PC vector. And let angle PAB and PBA, this is equal to theta, because angle opposites to equal sides are equal. Let angle PAB is equal to PBA is equal to theta. Now the electric field intensity E1, which is represented by PC vector, this has two rectangular components. E1 vector has two rectangular components. First is, if we draw a line parallel to BA, then this angle and this angle are equal, because if two parallel lines are intersected by a transversal, then alternate interior angles are equal. These two lines are parallel, this is transversal, therefore this angle and this angle is equal. As this is theta, this will be also theta. Now E1 has two rectangular component. One is E1 cos theta along PR. One is E1 cos theta acting along PR, which is parallel to BA. Because a vector R, this can be resolved if this angle is theta. This has two rectangular component, R cos theta, and perpendicular to is R sin theta. Therefore E1 has two rectangular components. One is E1 cos theta along PR parallel to BA, and second is E1 sin theta. This will be act along E1 sin theta along PF perpendicular to BA, and E1 sin theta acting along PF perpendicular to BA. If E2 is electric intensity at P, if E2 is electric intensity at P due to charge plus Q at B, then प्लस क्यू चार्ज है बी के ऊपर, इसके कारण इलेक्ट्रिक फील्ड इंटेंसिटी पी पर कितनी होगी, देन ई टू मॉडुलस दिस विल बी 1/4 एप्सिलॉन नॉट क्यू अपॉन बी पी स्क्वायर 1/4 एप्सिलॉन नॉट क्यू बी पी और ए पी उसी तरीके से निकलेगा जैसे ए पी निकला था, देयरफॉर बी पी स्क्वायर विल बी आर स्क्वायर प्लस ए स्क्वायर। अब ये भी पॉजिटिव चार्ज है और ये यहाँ पर भी पॉजिटिव चार्ज है, तो पॉजिटिव पॉजिटिव को रिपेल करेगा, तो इलेक्ट्रिक फील्ड इंटेंसिटी विल एक्ट अलोंग दिस, लेट अस से पीडी। नाउ E2 vector is represented by PD vector. Now E2 vector has two rectangular components of velocity. E2 vector has two rectangular components of electric field intensity. Yeah, E2 has two rectangular components. Simply we say one is E2 cos theta. Now this is E2 vector. This has two components. Now this angle is theta, this is also theta, because if two parallel lines are intersected by a transversal, then their corresponding angles are equal. This and this are corresponding angles. If this is theta, then this is also theta. These are two parallel lines, this is intersected by transversal, this angle is theta, then this will be theta. Therefore E2 has two components, E2 cos theta along PR, one is E2 cos theta acting along PR parallel to BA, and second is E2 sin theta. E2 sin theta will act along this PF, E2 sin theta acting along PF perpendicular to BA. Now E2 vector, this is equal to 1/4 pi epsilon naught q upon r square plus a square, and E1 vector is also this, as E1 vector is equal to E2 vector. हम देख रहे हैं E1 और E2 इक्वल हैं, as magnitude of E1 vector is equal to magnitude of E2 vector. Therefore E2 sin theta acting along PF, E2 sin theta acting along PF, and E1 sin theta acting along, we called it PF, now this called as PE, E2 sin theta acting along PE and E1 sin theta acting along PF, they being equal and opposite, they cancel each other. Therefore as E1 is equal to E2, therefore E2 sin theta and E1 sin theta being acting along opposite lines and equal, they cancel each other. वो इक्वल हैं और अपोजिट लाइन के अलॉन्ग एक्ट कर रहे हैं तो कैंसिल कर देते हैं. देयरफॉर रिजल्टेंट इलेक्ट्रिक इंटेंसिटी एट P, दिस विल बी, इधर एक्ट कर रहा है E1 cos थीटा और इधर E2 cos थीटा. देयरफॉर E1 cos theta plus E2 cos theta, but E1 and E2 are equal, therefore we can write it as 2E1 cos theta. Put the value of E1 की वैल्यू रखो यहाँ से, ये हो जाएगा 2 into Q upon 4 pi epsilon naught r square plus a square, and cos theta is, as cos theta in this right angle triangle, cos theta is based upon hypotenuse, therefore base is OA and hypotenuse is AP. Therefore E vector is equal to 2 into Q upon 4 pi epsilon naught R square plus A square. Substituting the value of OA, which is A, and substituting the value of AP, which is R square plus A square raised to power 1 upon 2. This will become Q into 2 into A, Q into 2 into A, 4 pi epsilon naught R square plus A square raised to power 3 upon 2. Now Q into 2A, now Q into 2A was equal to dipole moment. Therefore E vector is equal to P upon 4 pi epsilon naught R square plus A square raised to power 3 upon 2. This gives us electric field intensity at a point on equatorial line of the dipole. Now electric field intensity is acting along PR and the dipole moment is acting from negative to positive charge, as E vector and P vector are in opposite directions. They are in opposite directions. Therefore we can write E1 vector is equal to minus P vector upon 4 pi epsilon naught R square plus A square raised to power 3 upon 2. This means electric field intensity is in a direction opposite to dipole moment. If dipole is short, then 2A is very less than R. Therefore A square will be very less than R square. Therefore R square plus A square, this will be equal to R square. Therefore putting this value in this equation, we get E vector is equal to P upon 4 pi epsilon naught R square plus A square is equal to R square raised to power 3 upon 2. This will become R cube. Therefore E is equal to P upon 4 pi epsilon naught R cube. This is on equatorial line. Now on axial line the value was 2p upon 4 pi epsilon naught R cube on axial line. Therefore E axial अपॉन ई इक्वेटोरियल, डिवाइड एक्सियल को इक्वेटोरियल से डिवाइड करो तो ये 2 आ जाएगा. देयरफॉर इलेक्ट्रिक फील्ड इंटेंसिटी ऑन एक्सियल लाइन is twice the value of electric field intensity on equatorial line when 2 points are equal distance from the center of the dipole.